Welcome to the Four Worlds podcast from Tomorrow's World Today. We're diving into the latest in tech, science, and sustainability, from nature's mysteries in the world of inspiration to the hands-on crafts of creation, the bold breakthroughs of innovation, and the scaled-up wonders of production. This is your ticket to the stories shaping tomorrow. Welcome to another episode of the Four Worlds podcast. Today we are going underground with a company called Deep Isolation in their new way to dispose of nuclear waste. Joining us now is Baltzer. Rod, welcome to the show. We're really excited to have you, and we're really excited to talk about Deep Isolation.
Thanks for having me on. This ought to be a good conversation.
I think so, because what you all are doing over there is really fascinating, and that's where I kind of want to jump off at. If for anyone who may not know who Deep Isolation is, what Deep Isolation does, can you start there and address some of the challenges that you are trying to solve in the nuclear industry?
Yeah, so Deep Isolation is a company that is going to dispose of the commercial spent nuclear fuel out of commercial power plants. And we use directional drilling to do that. So we drill a borehole about a mile deep underground that can be vertical, or our patented technology takes that non-vertical. So think of directional drilling going horizontal, following a formation, and we can do that at various depths depending on the nature of that site and the waste. But this is something where it now allows you to co-locate this with waste generation. So at a power plant or at a reprocessing facility or something, and you also don't have to take the entire nation's waste. It can just be a very small subset. So it's really kind of opened up different conversations. We are a global company, and so we do this around the globe, not just in the U.S.
Interesting. And so where are you in that? Are you starting to get some traction? Let the people know kind of what's going on that front. How far along are you with this technology? Because it seems like you are already there.
Yeah, we founded Deep Isolation in 2016, and as everybody knows, there's lots of oil and gas technology. This is nothing new. This was really just saying, man, we could use this oil and gas technology in a different application. And if we do it in nuclear, we need a little bigger borehole. So it's 21 inches instead of 6 to 8 inches that they would normally do, but it's well within the technical realm. And so you're right, we've started developing the canister that would hold the spent nuclear fuel and the lifting attachment to make sure it could be handled by nuclear processes and equipment as well as oil and gas, and nobody drop it. Very key thing to our technology. But we've gotten very good funding through the Department of Energy's Advanced Research Projects Agency and other agencies, and been able to develop that technology and progress it. So we've done some small scale demonstrations at depth. So we took a 3-foot long canister about a half a mile deep and showed you could retrieve it out of that borehole as well. And then we took a full size canister and put it near surface. And we just kicked off in January our demonstration for a full-scale at-depth demonstration, just placed orders for the long lead items and hope to get to that later this week. Or not this week, this year, sorry.
No, you said
I wish
that's
this week, yeah.
Jumping the gun a little bit. So with all of that being said, it's all there. You have these things figured out. How do you see Deep Isolation's role evolving as the first mover states begin to deploy small modular reactors, or SMRs, and advanced reactors?
The thing that's changed with SMRs and advanced reactors is, particularly in the U.S., the contract has changed. So DOE makes them sign what they call the standard contract. And for the legacy fleet, all their storage costs are paid. But for these new guys, they're on the hook for their own storage cost. And so we're talking to almost every developer out there and making sure they're thinking about the back end, because that can be a pretty significant cost. And if you package it in our canister, you can store it above ground if you don't know what you're going to do with it yet. You can transport it between sites or to a different site. You can dispose of it in a mined repository if that ever comes back, or you can put it in one of our boreholes. And so, it gives you a lot of flexibility. And then I think this also kind of opens up the topic of, do you want to just dispose of it where it's at instead of transporting it through the state, and have those conversations up front so you don't have to have those kind of awkward conversations at the end when there's a mess to clean up.
Yeah, exactly. You said it best, a mess to clean up. And before we really start getting into kind of the nitty gritty of the technology, what it is, I do want to kind of, ask you, the problem that nuclear waste does cause, or a threat it poses, or whatever. what's the biggest concern of trying to find a safe way to dispose of nuclear waste? Just to give the audience a little bit of an idea, why something like this needs some sort of solution.
So nuclear waste is handled and transported and stored very safely, but it is very radioactive and it's thermally hot as well. And so if you did get close to it without any of the shielding or protective barriers or anything, it would kill you, flat out. And so it's something that you want to be very careful with. It's also very long-lived. And so we do a lot of probabilistic safety models and analysis. And we look at, if we have that waste form deep underground, how long until you get to a peak dose where somebody may get a dose on the surface, and that analysis shows that's about 1.6 million years into the future, and that dose is less than a chest X-ray. And so you can handle it really safely at these great depths, but having it out on the surface where you don't have that, and it's more, you can get corrosion or other things and whatnot. You just want to put that underground for those really long periods of time.
Yeah, just make sure it's safe down there and not exposed to anybody, because he said nasty stuff there. So how has your modular borehole technology kind of changed the conversation? We talked a little bit about, with local communities compared to the decades-long challenges faced by large-scale mining repositories.
Yeah, I think there's two things on that. One is just changing the conversation. I'm going to call it nationally. One of the things we see is like Finland, they've got a mine repository program. They're very close to getting that operational. They've done the construction, but they've been working on it for 30 years, literally 10 years to construct that mine repository, because you have to construct the entire thing before you put waste in it. You've got humans underground, ventilation and other things, lots of engineered barriers. And meanwhile, you've got politics that change, sentiment that changes, administrations, budgets. And so it's difficult for those really large programs to be successful just with those long timelines. When we start looking at boreholes, it takes us about 2 months to drill a borehole. And so now we've got a much shorter construction timeline. I don't have to do them all at once. I can start with one and then progress as I go. And so there's less capital requirement up front. So you can move a lot faster and on those timelines. So I think that helps, I'll say, from a national perspective. When we start looking at, states and local communities, we did a survey and basically 1 out of 3 Americans lives within 50 miles of spent nuclear fuel. Most of them don't know it, but they do, and it's fine. But we asked them, would you prefer to take that spent fuel that's above ground in storage and transport it long distances to a centralized repository? Would you like to just keep it where it's at? Or would you like to put it safe deep underground where it's at and not transport it through your neighborhoods? And 80% said, we'll take option 3. Just bury it safely where it's at. I don't want to see it again. And so it does change the conversation from, I don't want waste in my backyard to I've already got waste in my backyard. Now what am I going to do with it?
Right. It's like, surprise, surprise. You're probably near some sort of nuclear waste something. So having it underground, I think that's an easy answer for most people. And once you explain the technology like you have, I mean, it seems like a no-brainer, and it kind of leads me into my next question about the future of this stuff. How much of your future growth do you expect to come from direct waste management versus licensing your IP to other engineering and environmental firms like that?
Yeah, Deep Isolation does consider ourselves an IP company. We've got 99 patents now, and we continue to have others in the pipeline. It's across our entire life cycle. So how do you find a site? How do you know that's a good site and has been out of touch with the surface for 1 million years? How do you design the well, the canister? How do you plug that well? How do you monitor during operations and after? So it's everything associated with that. And there's a lot of other, operational know-how and things that we've gathered over the last almost decade. And so, we've got a lot to bring to that. We offer clients a choice. We've got a lot of supply chain partners that we can bring with us, and we can do the entire thing turnkey, bake in our licensed products and everything, or we can have a menu option. If they have a national oil company and they want them to do the drilling, that's fine. And we can sell them the IP license for the drilling, but not provide that aspect. And so it's really kind of up to them. For us as a company, we're going to make the most money off of that IP license, but we're happy to provide the service. We definitely want to make sure it's integrated and it's got the right quality and things. We get to the ultimate goal, which is put that safely underground.
You took the words right out of my mouth. With all of that being said, because there is so much that goes into this stuff, especially when you're dealing with so much red tape in this industry, the ultimate goal is safely storing nuclear waste. And I think at the end of the day, that's really important to keep in mind.
Yes,
for
sure.
Mm-hmm. And you kind of said this without saying it. These canisters are like a triple purpose. You talked about storage, you talked about transport, and you talked about disposal. What were the most significant technical hurdles in designing a canister that is triple purpose for such diverse waste forms?
Yeah, part of it was the waste forms. And so, when you look at some of the historic, what we've done in the U.S., it's all light water reactors, so pressurized water or boiling water reactors.
Sure.
And it's pretty similar fuel types and whatnot. But now you've got TRISO, their pebble form, or you've got molten salt, or you've got reprocessed waste forms. Some of these have a lot hotter thermal. Some have more radioactive dose and content and things. So as we looked at our canister, it's like, okay, where's the envelope? We need to make sure it bounds all of these things, and that can get pretty broad. And
Sure.
So trying to get a little bit more specific on these waste forms was really a key part of it. There's also, good regulations in place, standardized for storage and transportation, but borehole disposal hadn't been as thought out as some of those other regulations. And so there's a little interpretation that you have to do of, we think this is how it would be applied for a borehole, but include that in the process. So I think at the end of the day, we achieved our goal. We had a lot of review and advisors and stuff look through that, and we're pretty proud of the accomplishment that we've made.
Yeah, absolutely. I mean, I've written about, we have our website, tomorrowsworldtoday.com. I've written about deep isolation a lot because I am fascinated with what you guys are doing. Essentially, I'll say it straight up, because it is such a unique concept and something that really does need to be addressed, especially as nuclear energy is once again being pushed so much because of, data centers are the big one. Trying to get nuclear energy back on the forefront of clean energy is so important. And of course, you need to find a way to store it, the waste at least. So it is. Yeah. It is. The short story long, I should say. So how does deep isolation, maintain high nuclear grade quality assurance while using equipment originally designed for different environmental standards?
When you think about quality assurance, you really ought to think about processes instead of the equipment. And so a lot of this is making sure you've got the right procedure. And so when you go into a nuclear facility, they've got lots of procedures and lots of check marks. And it's, do you have this wrench? Is it torqued? When's the last time it's been certified? Is it made out of the right material? Just to get it into the facility. And so as you kind of go through that process, it's more the process of, are you collecting the data? Are you analyzing it? Do you have how do you know you've got the right waste in front of you? Is it the right canister? Have you marked it down on the paper? Have you visually laid eyes on it? Have you done a sanity check? And all that as you go through, even as you check, ropes and cables, wear and tear, maintenance packages and things, it's all kind of proceduralized toward that. And so the biggest aspect, I think, is just, nobody wants to drop anything. Nobody wants to do anything that's going to be off normal. And so, as we have gone through and started to develop these procedures and operations, as we've done our testing, we've learned a lot. And so we start to capture that knowledge and put those into the procedures to make sure we don't make any mistakes like that in a live environment. So all of our stuff right now has been, cold tested. It's not radioactive. And so, it's still, some of this is heavy, and we've got definitely, safety hazards, but at least it's not got the radioactive aspect to it yet. So we can still kind of mock it up and test it and make sure we get all the lessons learned before we do that in a live environment.
Yeah, absolutely. And I'm sure there's some things that still kind of, present some challenges. And we talk about waste forms, we kind of generalize that. What specific waste forms still present sort of a challenge, an engineering challenge at the very least, for your borehole disposal model?
So most of the waste forms fit pretty nicely. They're fairly compact and whatnot. There's always a little bit of a tension, I think, between the bigger the canister, the fewer the canisters you need, the fewer boreholes you need, so it'll be more cost effective. But the bigger the diameter of the borehole, the more it's going to cost to drill that well. And so there's always this kind of, I'd like the canister as big as possible, but I want the borehole as small as possible, but the canister has to fit in the borehole.
Right.
And so that's the biggest dynamic. And so for some of these waste forms, I'll use triso pebbles. You could put, one pebble each and have a very, very small, narrow canister, but you're going to have a lot of canisters. So if you can make that wider, they fit in there, they're a little bit more compacted and they have more volume. But, that's some of the trade-offs as we go through it.
Yeah, sure. It makes sense. And I don't think we really talked about this. What goes into picking kind of the perfect spot to drill your boreholes? And I'm sure there's no perfect spot per se.
Yeah, and we'll say the beauty is we don't have to have a perfect spot.
Yeah.
So for some of the mine repositories, you've got to have a geologic formation that's fairly near to the surface that still, is going to be isolated and whatnot. And it may get difficult to find those. For us, we can usually go deeper. So if we thought we were going to be at 1 kilometer, but we didn't see anything that was a good formation, maybe we're at 2 kilometers. The deeper you go, the more isolated it is, the thicker those brines and the less transfer there is toward the surface. And so, what we've found is that, we did some research, and like 80% of the nuclear power plants out there look like they probably have a decent geology next to them.
Right.
You'd have to do site specific, and not every community is going to want it. But it is something where we think this is broadly applicable, whether it's shale or salt or granite or some other formation. But there's usually something that's been fairly isolated and it isn't in a high seismic or some other area like that.
Right. Makes sense. Interesting. And just curious, picking that spot, it's something that's so simple. It's like, sometimes don't think about it. So you touched on a little bit of the directional borehole design. How does that kind of improve the safety and feasibility of retrieving waste canisters compared to traditional vertical boreholes?
When you think about these canisters, remember that they're pretty heavy. Uranium is a heavy metal, and they actually weigh it as metric tons of heavy metal. And so as you start to stack these canisters, it could potentially, crush one or do something like that. So you need to build in engineered supports as you go in a vertical kind of situation, depending on how deep you are, how many canisters and such. When you do it horizontally, then they just lay on their sides in the bottom. So you don't have any support structures. You don't have to think about that or engineer that into your well. And so it works also in retrievable. As you retrieve it, that you can pull those out and it would be, just basically sliding them off. You don't have to worry about deconstructing some of your engineering supports as you go through there.
Right. And with that recent groundbreaking at your Halliburton facility in Texas, what are the key success metrics that you hope to achieve during this multi-year full-scale demonstration before moving into radioactive to hot? You talked about the hot radioactive waste.
Yeah, our demonstration is going to be 2 phases. So the first phase that we've kicked off is the subsurface. And so the main purpose of that is drill that full-sized hole. We know we can do it. The drillers know they can do it, but our customers really want to see that. They want to be able to show their local communities or regulators or others what's going on. And place that full-size canister, and we'll place a couple of them and then retrieve it out of there. Show it can be retrievable. Nobody really wants to retrieve it. We don't think we'll have to, but we have to show we can if we need to. And so that'll be our success, is drill that hole and retrieve that canister. And so, check number 1. The second phase of this is the surface. And so this will be, assume that a cask has shown up at the site with waste. How do you get that waste canister off the transport to the wellhead and then deployed downhole in a shielded environment, protecting everybody, not drop it as we go through it. And so that'll be part 2 of it as we go through. So that'll be great to have that kind of end-to-end demonstration.
Yeah, absolutely. And of course, after the demonstration, we are looking towards a first-of-a-kind commercial project. Let's say in the next 3 to 5 years, what does that ideal first-of-a-kind commercial project look like for you in deep isolation?
Yeah, we're excited. We think there's been a lot of movement toward trying to find a solution for some of this. The Department of Energy recently put out a request for information for nuclear life cycle innovation campuses. We needed to include a disposition path in there. And so I think that's opened up a lot of discussions in the U.S. We also see overseas, there's a lot of interest. We see what's happening with, Russia invading Ukraine and tank shells being shot over spent nuclear fuel on the surface. And it's gotten everybody to think we need to get this below grade. So we think there are a lot of opportunities out there. Our ideal is, yes, we put radioactive waste in a hole, exactly where that is, how deep that is, what that looks like, how many canisters. We really don't care that much. It's just getting that first one done and showing that, yes, it's now safely out of harm's way.
Yeah, makes sense. And I kind of want to, as we wrap this up, just kind of leave you with kind of more of an open-ended question, just for a general audience listening that might not have so much knowledge about nuclear energy, nuclear waste disposal, retrieval. What is something that they should know about this industry as we move forward into the future?
A lot of times we get information about radiation and it's scary because you don't understand it. You can't smell it, taste it, feel it. And so it's hard to understand. When I talked about our safety analysis, peak dose getting there, and it's 1,000 times less than a regulatory limit at 10 millirem, that's a banana. Banana has potassium is radioactive. And so you can pick that up just, at your grocery store. So not all of it's bad. Some of it's healthy and it's part of my breakfast every morning.
Yeah, right.
But, part of this is, nuclear waste has also been handled and transported, millions of miles. There is a lot of experience around the globe on this. So it's not something we haven't done. We just haven't disposed of it. I don't know why we like to keep it. It's very compact. Your lifetime of nuclear waste generated from all the electricity you use is a Coca-Cola can worth. It's super compact, and it is a solid. It's not green goo sludge off The Simpsons or anything like that. So, I've been doing radioactive waste for 25 years.
Wow.
And it's a fascinating industry. There's lots of wrinkles in it. I encourage anybody to learn more about it, but it's something that's handled safely. We've learned lots of lessons from cleanup mistakes in the past, but I'm really optimistic about the future for it.
Yeah, absolutely. I think you said it best. If you're interested to learning more about it, definitely do so. It is, like you said, fascinating topic, and you can find Deep Isolation at their website. Any other channels or anything that people could check out if they do want to learn more?
Yeah, our website, deepisolation.com, and we've got publications and other things, but we also have a YouTube channel, a lot of videos out there. Yep. So check us out on either of those.
Yeah, absolutely. It's important to learn about this stuff. So, Rod, I appreciate you taking the time, kind of teaching me and hopefully teaching the audience a thing or two about nuclear waste and the fascinating stuff that Deep Isolation is doing. So thank you so much for joining us.
I've really enjoyed it. I appreciate the conversation.
Yeah, I'm glad you did. Good having you, Rod. We'll be talking soon. That's all the time. Thank you, everyone, for listening. We'll see you next time.
Thanks for listening to this episode of the Four Worlds Podcast. Until next time, you can catch up on the latest innovations shaping our world at tomorrowsworldtoday.com. Follow us on Facebook and Instagram, and be sure to subscribe to our YouTube channel.